Hello everybody and thank you for joining me. The focus of this presentation is on healthcare data breaches, a growing and costly challenge facing the US healthcare sector. In 2024, the average cost of a healthcare data breach reached an alarming $9.36 million per incident, the highest among all industries. But the financial burden is only part of the story. These breaches threaten patient privacy, compromise safety, and undermine public trust in institutions tasked with protecting sensitive information. As more patient data is collected and stored electronically, the healthcare industry must also navigate a complex web of federal and state regulations, which adds another layer of vulnerability. Together, these trends, increasing digitalization and regulatory complexity, create a perfect storm for cybersecurity risks in healthcare. And that's what this study set out to investigate. This study was guided by three main objectives. The first objective was to explore how healthcare data breaches have evolved over time in both scale and complexity. Secondly, the intention was to offer actionable insights that can help improve cybersecurity efforts in the healthcare industry. And thirdly, the research study was to systematically address four key research questions. Research question one looks at overall trends, how often breaches happen, and how large they are. Research question two focuses on the geographical distribution of breaches. Are some states more affected than others? Research question three examines the types of breaches and the locations of the compromised data. Research question four investigates the response strategies organizations have used and how those have changed over time. These questions help paint a comprehensive picture of the evolving cybersecurity landscape in healthcare. The dataset used in this study comes from the U.S. Department of Health and Human Services Office for Civil Rights, commonly known for its public breach portal or the so-called Wall of Shame. This analysis focuses on breach reports submitted between 2009 and 2024, which were retrieved in January 2025. After cleaning the data, removing duplicates and records with no violations, we were left with over 6,500 breach records. Each record contains valuable details, including the breach date, the covered entity, the type and location of the breach, how many individuals were affected, and in many cases, a web description explaining the incident. These fields form the backbone of our analysis in identifying breach trends and organizational responses. To carry out this study, we used Python as the primary tool for data cleaning, analysis, and visualization. The methodology involved several layers. First, we performed statistical analysis to identify breach frequency, size, and extreme outliers. We then used natural language processing to mine unstructured web descriptions and identify common response actions organizations took after breach. To uncover hidden patterns in breach types and locations, we also use the K-means clustering, which is suitable for categorical data. And finally, all findings were brought to life through data visualizations, including heat maps, line graphs, and box plots. Let's start with the first research question. What are the trends in breach frequency and size? From 2010 to 2018, the number of reported breaches steadily increased, but beginning in 2019, we saw a surge. peaking around 2023. In 2024, there was a slight decline, which may reflect stronger security controls and reporting or other stabilizing factors. But when we look at the number of individuals affected, the story gets even more serious. From 2010 to 2014, the impact remained relatively low. Then, in 2015, just three massive breaches exposed data from about 100 million people. Since then, the number has crept upward until another major spike hits in 2023 and 2024, including one breach alone in 2024 that affected 100 million individuals. A box plot of breach sizes over time also shows increasing variability and the growing number of large-scale outliers, breaches that affect tens of thousands or even millions of individuals. These trends suggest that while breach detection and response may be improving, the scale of risk continues to grow. The second research question asks, how are healthcare breaches distributed geographically? Table 1 on the slide shows the top 10 states by number of individuals affected each year from 2010 to 2024. As you can see, California, Texas, and Florida appear repeatedly across years, indicating they consistently face the highest breach risks. This likely reflects their large populations, greater digital infrastructure, and a higher number of healthcare organizations, making them attractive targets. Interestingly, states like Arizona and Wisconsin begin appearing more often in the top 10 in recent years. This could suggest either increasing vulnerability or improved reporting. Overall, the findings show that breach risks are geographically uneven, and high population and economically active states are the most consistently affected. This heat map deepens our geographic analysis by visualizing the number of individuals affected by breaches in each state from 2010 to 2024. The darker the cell, the greater the number of affected individuals in that state and year. The numbers are shown on a logarithmic scale to accommodate extreme differences. We see persistent dark areas in California, Texas, Florida, New York, and Georgia, pointing to high risk breach severity in those regions. Midwestern and low population states like North Dakota and Montana are lighter, suggesting fewer or smaller breaches. Some states like Arizona, Illinois, and Indiana show temporary spikes, reflecting large breaches in specific years. Overall, the darker trend intensifies post-2015. This heat map shows how the top three breach locations have evolved over time, from 2010 to 2024. Notice how network servers dominated the rankings in recent years. This indicates a major shift in attack focus from isolated devices to centralized systems where large volumes of sensitive data are stored. Email appears consistently from 2016 onward. This reflects its ongoing vulnerability, often exploited by phishing or account compromise. Interestingly, paper films show up throughout the period, although their prominence declined. This suggests that physical breaches haven't disappeared, but are becoming relatively less common. Laptops and desktops, once common breach points, are now far less frequent in top rankings, likely thanks to device encryption and endpoint protection. Overall, this figure illustrates a clear migration from physical to digital breach locations, with modern attacks increasingly targeting network infrastructure and electronic systems. This heat map tracks the top 5 breach types each year from 2010 to 2024. The most striking pattern is the rise of hacking and IT incidents, which consistently rank number one since 2016. This reflects the growing threat from cyber attacks targeting digital systems rather than physical theft or mishandling. Unauthorized access or disclosure, often involving internal errors or mishandled permissions, has remained a steady concern across all years. Before 2015, theft was a leading cause of breaches. However, its role has declined significantly, likely due to improvements in physical security and encryption for laptops and devices. Improper disposal and loss show up occasionally, but are less common. Altogether, these trends show a clear shift toward digital and technical vulnerabilities, demanding stronger defenses against cyber intrusions. To uncover deeper patterns in how breaches happen, we applied key modes clustering based on breach type and location data. The algorithm identified 4 distinct clusters. Cluster 2, the largest, contains over 2,200 breaches, mostly involving network servers and hacking IT incidents. It shows a steep upward trend, highlighting the growing threat to centralized digital data infrastructure. Cluster 3 includes breaches involving laptops, desktops, and other portable devices, often due to theft or loss. This group has declined over time, likely due to better endpoint security. Cluster 1 is dominated by email-based breaches, particularly hacking incidents, and is steadily increasing, reflecting persistent phishing and email compromise threats. Cluster 0 is the most diverse, including paper films, email, EMR, and unauthorized access. It reflects a mix of technical and human error related breaches. Together, these clusters show how breach profiles have shifted from physical loss to server and email based. To analyze how organizations respond to breaches, we relied on the web description field in each report. These fields often include narrative details on corrective actions, notifications, or retraining steps taken. However, as this bar chart shows, not all breach records include a description. In 2024, only 114 breaches included a web description when we were conducting this research. This has important implications. First, it means our ability to assess response trends in the most recent year is limited. Second, it suggests there may be delays in reporting or inconsistencies in what entities choose to disclose. Despite this limitation, we were still able to extract meaningful patterns from the thousands of available descriptions across the years, which I will show on the next slide. This figure shows a timeline of the most frequently used action words in web descriptions, normalized by the number of available records per year. 4 key response verbs stand out: provided, implemented, notified, and retrained. Notice that both notified and retrained show a clear increase in recent years, suggesting a more transparent, and workforce-centered approach to incident response. On the other hand, terms like encrypted were more frequent in early years and then declined. This may be due to the HIPAA final rule in 2013, which pushed for protective encryption, reducing the need to mention it in post-breach reports. To conclude, this study reviews a growing and complex landscape of healthcare data breaches. We saw that breach frequency and scale continue to rise, particularly from 2018 onward. California, Texas, and Florida remain consistently impacted, but emerging hotspots suggest shifting risk. Technologically, attacks are increasingly targeting network servers and email systems, reflecting digital transformation in healthcare. Meanwhile, human factors like unauthorized access or phishing remain persistent vulnerabilities. On the response side, we observed growing emphasis on notifying stakeholders, retraining employees, and implementing corrective safeguards. The findings underscore that healthcare cybersecurity must address both technical systems and human behaviors with data informed and adaptable strategies. Thank you. I look forward to your questions.